to question 12, and this is topic 4, November 25, paper 1 DTHL. It applies to SL2, and I actually already covered question 12 and 13, but my video sort of malfunctioned, so I'll just do it again, and I have my material here that I already covered. So I would like you guys to do these questions first, and I'll just bring that back to help explain. And I've covered all the previous questions, so definitely go check that out in the playlist, and more videos coming soon. So on to question 12, we have a rope climbing question. Is a versatile exercise that delivers strength and mobility for a full body workout. Steel frame fixed to a concrete surface, such as a ceiling or a wall, while a thick rope is attached to the steel frame for the user to climb. And we have this image here. Which property makes the rope suitable to use for climbing? And we have these 4 options. So complete this question on your own. Try to figure out the answer. And come back to this. So I'm gonna play it now. Okay, now I've brought back this. In fact, wait, let me go back. I want you to do question 13 and 14 as well. So let's look at question 13 and 14. We have a production method that manufactures, produces, processes components without interruption. So these are our options. And then we have, why is fiberglass considered a composite material? So these are our 3 questions that I want you to do. Come back to this. And now I'll show you our answer. Okay, so this is how I explained it. We have the ceiling up here, right? Let me use a different color. We have ceiling, and we have this guy's arms, right? His weight, let's say. He is pulling the rope down, and the ceiling is pulling the rope up, right? So let's put his arms here, right? So he's pulling the rope in different directions. The rope is being pulled in different directions, so there's a pulling apart force, and that is what we call tension, right? And so the ceiling pulling up and the climber pulling down. That's what we discussed here. Then I just defined every option here. Toughness is the ability to resist cracking or the propagation of cracks. And so I talked about, an Apple Watch. We want our cracks to not propagate. So if we hit, for example, hit this part with a hammer, if I hit this section with a hammer, I do not want everything else to crack, right? That's dangerous, and that is not a tough material. The material would have low toughness in that case. And so that is what toughness means. And toughened glass is used for laminated glass for windshields. What we have is a plastic layer sandwiched between 2 layers of toughened glass. Toughened, or we say tempered. Toughened, tempered glass, right? And now ductility is our ability to be drawn or extruded into a wire, right? And I talked about plastic. The main thing with ductility is about metals, and usually we talk about copper being able to uh, be drawn into very thin wires, which is why we use it for our electrical work. But we can also have extrusion of plastic, right? So we have a ram, and we sort of ram the molten plastic into a extrusion, let's say, mold, and it comes out with this constant cross section, extruded, right? Constant cross section. Okay, And then we have our hardness. Hardness is our ability to resist scratching and penetration of that material. So again, the example of a smartwatch or a smartphone, we have um, a phone case, right? Or the covers that we put on top of our phone, screen protectors. So screen protectors need to be hard, right? Need high hardness or scratch resistance, right? And so these are the equivalencies we have to draw. And then we have, they also need to be tough, right? Impact resistance. If I drop it, I don't want the whole screen to crack. Maybe a small portion of it cracks, right? And so that's called toughness. And so I've dropped my phone several times, but only the part that's dropped, the part where it fell, has some cracks. And I'm very lucky for that. And so that is our toughness. Now we'll move on to question 13. Uh, they're asking production method. I'm sure you guys already saw this question and tried it out. So our answer is continuous flow, and that's because we're talking about without interruption. So that is our products like consumer goods, uh, let's say everyday consumer goods, everyday popular consumer goods like a can of Coca-Cola, consumer goods, right, that need to be continuously produced 24/7. So continuous without interruption means 24/7, right? Mass customization, that's the large scale personalization of products. So we have a high output just like mass production and continuous flow, but now we're using CIM systems. For those of you who are HL, we have computer integrated manufacture. They're highly efficient. That gives us economies of scale, and so we can produce 1, 10, 100, 1,000 products. And either way, we're still benefiting from economies of scale with things like maybe advanced 3D printing. Nowadays, we can uh, 3D print boats, and so it's very easy to customize, right? 3D printing. This means they're made to order, made to the individual customer order, and so that's what we did there. Then we have mass production. So mass production is large scale, large volumes, just like continuous flow, but not 24/7, right? And it's not customized. It is a standardized product. So there's a high rate of production and high productivity that gives us improved efficiency and also economies of scale. Now, automated production just means involving machines, and those machines are controlled by computers. We can't just say involving machines because we can have mechanized production. That just means involving machines that are controlled by humans. That is mechanized. So automated is this. Now, on to question 14. I started this, but it did not record. So here it is. Why is fiberglass considered a composite material? It is made of at least two different materials. We know that is true, right? That's a composite. And fiberglass is what? This is something we should know. Fiberglass is essentially equal to, it's the same thing as glass reinforced polymer, so glass GRP. You guys can search that up. And it is essentially made using uh go to glass fibers plus a polymer resin, right? Thermosetting polymer resin. So we have things like poly the resin is epoxy, right? That's our thermoset. And then we have from vinyl, polyvinyl. We can have polyester as well. And then we have some additives, right? That combine the two materials and make them set. So additives, and sometimes that can just be some kind of glue or some adhesive. or things like uh, catalysts when we're talking about chemical reactions. And so that is what we mean by fiberglass. So let's look at this. It is held together with an adhesive. That's what we talked about. That is what helps it bond together. Right? Helps the two materials bond. Helps bond the materials. So that is what defines a composite, these two ideas. And then we have, is it recyclable? That is not a definition anyway. Recyclability is not a definition for composites. And I don't think fiberglass is recyclable either because it has adhesives and it has two different materials that are bonded together. That makes it really hard to recycle. So it's really challenging. Challenging to recycle. Okay. So that made it a bit faster for us since we already went through all of this. And so now question 15, this is still topic 4. Which aspect is an advantage when working with single task robotic systems? Definitely try this question out yourself and then we'll go through the answers. So we have the robot can work autonomously without interaction from a human. So work autonomously without human supervision or interaction. Single task robotic systems. So that is usually that could be possible, but it's usually not the case, right? Usually we need a human input. Usually need usually needed, right? But what we mean by a single task robot, let's first define that. Single task robotic systems, that is our robots that can perform only one task, only one. And they do that perfectly, right? But they might need human support, if especially if they're first generation or second generation. Then we have the robot can communicate with other robots to share information. That is not the case, right? That is our and that is our second generation robot, right? And third as well. So anything after second generation can communicate with each other and share information. They synchronize with each other and do not need constant supervision. Then we have the robot can sense when a product is not in the correct orientation. That is again second gen, right? It could be single task, but that's not the main benefit, right? Second gen, it has sensors equipped with sensors, so it can sort of learn from its environment, equipped sensors to adapt to its environment, to adapt or provide info about environment or surroundings. Right? Hopefully that makes sense. Not a bot about. And next is the robot can repeatedly perform the same task to the same quality. That is exactly what we just said, right? Can perform only one task to the exact same quality. There's no variation, right? That is why we want to use a single task robot for simple tasks that maybe don't need to be too high quality or need to adapt to surroundings. Now we have which wasting technique is appropriate for metals, woods, and plastics and involves spinning the material around its central axis while applying a cutting tool to create a vertically symmetrical shape. Okay, this is a wasting technique, so definitely try this question out, guys, and then come back. Is appropriate for okay, so this would be turning, right? Right? So the answer is clearly turning. Casting is a molding process. It's an additive sort of molding process. It's not wasting. Not equals to wasting. And they tell you it's wasting already. So of all of these, the only one that's wasting is turning. So you actually just have to do process by elimination if you don't know what turning is. Fusing, that is, let's say, soldering, uh, welding, that's a joining technique, is equal to joining technique, not wasting. Wasting is subtractive, right? And then we have 3D printing, that's again additive. So this would be molding, not additive, I guess. This is additive. Again, not wasting. So the only one that is wasting is turning, and this is the exact definition. And so essentially what we have is we have a central axis. In fact, let me use the space down so we have a better diagram. And you guys can search this up too. So turning, we have a machine maybe like this. And we put our workpiece into here, or let's say into this. We have a larger machine that attaches to this. Okay, and we put our workpiece in here. Let's say it's circular, right? And what we do is we have, maybe we do something like this. And so we have a metal piece or a machine that sort of takes this out. Definitely search this up better. You'll get a better idea. In fact, I'll just draw a simple diagram so that it's clear. We have something like this. And we might even just have a person holding something here to subtract this part of our initial, right? And what we did is subtract this part and only kept this, right? Hopefully that makes sense. But definitely search up and you'll get a clearer view of that. Now we have topic 5, so that's it for topic 4, and hopefully that helped. And hopefully you learned something. So do drop a like and subscribe if it did help, and any comments, any feedback definitely helps me. Otherwise, have a great week and wish you all the best.